Hello, thanks for joining on day 12 of Advent of Code. So we're almost halfway through the puzzle and no, I clicked. And we have a pretty nice picture starting to show. So this almost looks to me like it's printing cool or cold. So let's see what today's solution will bring. All right, day 12. Subterranean sustainability. The year 518 is significantly more underground than your history books implied. Either that, or you've arrived in a vast cavern network under the North Pole. Is my audio okay? I changed the mic a little bit, but should be fine. Okay. Let me know if it's hard to hear. After exploring a little, you discover a long tunnel that contains a row of small pods as far as you can see to your left and right. Okay, so we have a long tunnel with one row of small pods left and right. A few of them contain plants. Someone is trying to grow things in these geothermally heated caves. The pods are numbered with 0 in front of you. To the left, the pods are numbered -1, -2, -3, and so on. To the right, 1, 2, 3. Oh, okay, so if I spread out my arms left and right, then that's where the pods are going. So 0 in front of me, and then -1 and +1. Your puzzle input contains a list of pods from 0 to the right, and whether they do or do not currently contain a plant. Okay, a list of pods from 0 to the right, and whether they contain a list of state, the initial state. No other pods currently contain plants. Okay, so this input, oh, it's actually 0 indexed for once. I'm sure I run into off by 1 errors again, but good to know. And I guess at the beginning I don't have any negative ones, so I definitely don't have anything on my left. Your puzzle input also contains some notes you find on a nearby table. Someone has been trying to figure out how these plants spread to nearby pods. Oh, plants are spreading. Based on the notes for each generation of plants, a given pod has or does not have a plant based on whether that pod and 2 plants on the side of it had a plant in the last generation. These are written as L as C, R goes to N, where L are the pods on the left, C is the current pod being considered, R are the pods to the right, and N is next generation. Okay, you puzzle input some notes you find on a table. Based on the notes, based on whether the 2 on the left, the 2 on the right, and the pod had 1. Okay, so if we have a note like it has 1 in the current pod but not left and right on it, then the next generation it won't have 1. Note like if all the neighbors had 1 but the pod itself didn't have 1, then we don't have 1 in the next generation. And note, okay, so if it had 1 and then in this pattern, okay. It's not clear what these plants are for, but you're sure it's important. So you'd like to make sure the current configuration of plants is sustainable by determining what will happen after 20 generations. Oh, hi, function? Fin? Instructions are a little confusing at first. Took me a few minutes to understand the problem. Yeah, I'm still in the reading phase. Okay, so we have 20 generations. You'd like to make sure that the current configuration is sustainable by determining what will happen after 20 generations. So we have some input and we have some notes. Okay. Then the next, what language did you solve this in? Oh, and they grow to the left. Okay. The generation is shown along the left, where 0 is the initial state. The pod numbers are shown along the top. 0, 10, 20, 30. Oh, and they start with 0 and they end up at like -2. Negative number pods extend to the left and positive pods extend toward the right. Remember, the initial state begins at pod 0, which is not the leftmost pod. Okay. After 1 generation, only 7 points remain. In this example, after 20 generations, adding up all the numbers of plant-containing pods after 20th generation produces 325. So I'm adding up every row of plants. How do I get to 325 here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So it's around 20 times 10 is 200, and then 10 times 10 is 100. Okay, so we get to 325 by counting them at every generation. So after 20 generations, what is the sum of the numbers of all pods which contain a plant? All right, so we have an initial configuration, and then we can look at every single one of them, find them in the other instructions, write down the next generation, and then count those that have that one. Okay. Yeah, so if you solved this before, I'd be interested to hear in what you were working with. And I'd love to read your comments and questions, and also if I get lost or anything, help's always appreciated. All right, puzzle input, initial state. So exciting that we're already on day 12. Okay, so the first row says initial state, and then this dot belongs to the input. That's not like a dot at the end of the sentence, right? Wait, why is there a dot? Are there any more further out that I cannot see? No, that wouldn't make sense. Okay, and then I have a bunch of rows like that. And what's the test input? So here's the test input. Nope. Sometimes even copying and pasting is hard. So nobody say you have an easy job if you just copy and paste things. All right, let's get started. Okay, I'm reading the input, and now that I have the input, I need to do something with it. Okay. If the line matches the word initial state, then we want to say initial state if line that match, let's use parentheses, is equal to line that split, let's split at empty ones, 0, 1, 2. day 12. All right, that looks like we're getting the initial state. Great. Oh, and if you're wondering, I'm using fs.promises, so not the regular old school file system module, but .promises, so I can work with async await instead of worrying about callbacks and having everything shifted to the right. Okay, so we got the initial state. Don't need to do the rest of the line. So otherwise we want to do, we're splitting the line. Are we splitting the line? I want to say we split the line on these empty ones, and we let should we call it input or old generation? Old, comma, then we have the array, and then we get next. I just use a string for the state and remember the index by counting negative index parts. Okay, let me pass this. I just use a, what language were you using? Oh, also Node, cool. Wait, and you're counting negative index parts, so you're always shifting stuff? Does it matter where these things are in relation to me? Or does just the total of it matter? I almost feel like it doesn't matter at all where they are with respect to me. So I want rules to be a map, and that rule contains you need to know index of each part. Why do I need to know the index? Don't I just want the sum? But did I misunderstand the problem? So we do the next 20 generations, which also means the first generation is 0. The 1 input 0 match the, okay. Okay, in this example, after 20 generations, the paths shown as sharp contain plants, the furthest left of which is part -2, and the furthest right of which is 34. Oh, adding up all the numbers of plant containing parts after the 20th generation produces 325. So I'm adding up -2 plus 5 plus 6 and so on. Oh, thank you so much. I would have like totally went the wrong direction with that. Okay. So you are using an array. You use a string for the state and remember the index by counting negative index parts. Also, you have one string and you separately know what's the starting point for that one. Okay, that sounds good. But I'm not even there yet. I'm still in the phase of just parsing the input. So I have old and next, and then let's see if that is even the right thing. That looks good to me. Okay, so I have old and next. And what do I do with old and next? So I have these rules which are a map. 10 hours on the second part? Oh shoot! Well, maybe we only do the first part on the stream. Let's see how it goes. Oh, but also you know a solution now, so we might be actually really fast. Yeah, that's awesome. Then I won't get stuck for 10 hours and I can actually get some sleep. All right, but let's see first how it goes. Okay, so I want to put in the pattern And the next one, where pattern is a string, the next is also a string, but with just one character. Okay. So I have an initial state, and I have those, and I need to do rules.set, and I'm setting old with next. After I figured out how to solve it, it only took 10 minutes add on to the initial solution. Okay, well, so I guess it's up to you whether we're here for like 10.5 hours or 40 minutes. Assuming I get part 1 to run even. Okay. So we have the rules. And what do I do now that I have the rules? So I want to, next generation is taking the initial state and the rules. Let next generation is a function, takes the initial state and some rules. Oh, I would be interested. You said you solved it with Node 10. Are there any cool ESNext features that you were using or that you were like discovering while you were solving the puzzle? Anything you want to share? Not really. Okay. Well, if you find anything cool, please share it. I love to see new tricks that make JavaScript more readable or less readable in some cases. Okay, I'm going through the initial state. My rules have all the input, and the input has length 5. So I think what I want to do is let substring, and honestly I can never remember the substring syntax, so let a equal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, no, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. The splice or slice, which one is doing what? Oh, maybe I can do that slice is a method. Where's the help? Okay, so slice mutates the string, so that's not what we want. And then the other one is splice, split into substrings using, no, split is just splitting. Slice, splice, somebody help me out. What's the other one called? Oh, splice mutates. So slice might be the one to use. So slice has a start and an end. Okay, I want slice and not splice. Thank you. The index to the beginning of the specified portion, the index to the end. So slice, and we're starting at I, and we want to do I plus 5. So if we do I, that's slice of 4, 4 plus 5. I'm expecting to get starting at 5. Yeah, and it's 1, 2, 3, 4, 5 long. Okay, that looks good. And so we have the substring, and now we do rules.get of this substring. And that's the new one. Oh, I see. I have to look at those coming left of it. Ooh, tricky. Okay. Because I want to look at -3. No, I might even have to look at, could -5 be changing? I mean, could there be a rule that has nothing on the left? I guess not, right? Otherwise the thing would just be infinite right away. So we're assuming there always has to be one that needs to be set. So I can go 4 to the left. Okay, I -2 to I +3. And how did you fill, did you like pad? I guess I need to pad the initial state, right? Initial state equals, why are you only doing -2? Shouldn't there be, so if, oh yeah, -2 plus initial state, and then there could be 2 others, because I need to write this down. If my string is sharp and then some symbols on the right, and I have a rule that says nothing on the left, nothing on the thing itself, and then a symbol. What if I have a rule, what if I have this rule? Wouldn't I then need -3 on the left, +3 on the right? Would I even need 4? So this is 0, -1, -2. Okay, no, I need 2 here. And then if I have, so if this is my string, and if I were to have a rule that says have a pod, have an empty one, and that turns that one on, then I also need 2 dots on the right here. Okay. I guess I didn't really need to figure that out. I could have just padded by 5 and not worry about it. Okay, so now I can go through the initial state. And substring, that looks a little bit wrong. That should be initial state that slice, rules that get substring. So we get the next one. Next is an empty string. And now we want to do next plus equals this here. Okay, so now we have to remember that we're going 2 to the left every time. So we have an initial state in the rules, and we want to return next, and I need to do some processing on this. For let I equals 0, I less than 20. We're just doing 20 generations, right? Okay, so we do this, and then the processing here is let left equals 0. After the first round, left is 2 more to the left. Okay, so I have this, and now for let I equals 0, I is less than next, that length I plus plus. Okay, so now I'm going through the last generation. And if I is 0, then left is whatever that left number was at the end. So now I want let sum equal 0, and at the end I want to print the sum if next of I has a pot, sum plus equals I'm just adding up all the pot numbers, right? Yeah. The index, and I have let index equal left, and every time I go one to the right, I have to do index plus plus. This is a few too many variables, but that's okay, I think. So before we do this a ton of time, let's just do it once. And I'm running next generation, so I want to run next. I guess we can run it. Do we want to run it 20 times? Next length, no typo in length. You know what, let's just run the whole thing. There's probably some typo in it anyways. Yeah, 0 doesn't quite sound right. So next generation console.log. What does this look like after 20? All right, it didn't look like much at all. So next is the empty string. Substring is this. Console.log rules that get. Yeah, rules that get substring, and this is for this substring, this is the rule. Oh, how do I never get in here? Initial state -5, initial state that length -5. All right, I'm getting a bunch of undefines. Oh, because the test input, yeah, I'm running on the test input. The test input doesn't have the dots. So where was I doing this? Old next, and I'm using next, and if next wasn't set, I'm using a dot. Nope, nothing. Rules that said old is either next or dot. And let's just do this once for now. Oh, it's going too fast. Okay. I'm not even printing this. Where am I printing this? I'm printing rules that get of substring. So I'm getting those substrings. Oh, duh. So if the substring is not in, I want to do rules that get substring. Let pot equal, otherwise I just get copy and paste error. Rules that get of substring or a dot, and then here I'm setting the part, and then next increases by whatever the part was. Okay, that doesn't look too bad. So now we don't need to print all of those. And let's do this for 20 generations and then sum them up. And why is it printing exactly the same one as before if I'm doing this for 20 generations? Oh, initial state. Yeah, next is next generation and initial state is next. And it got really short and I only have one left. So that doesn't look so good. Let's put this in here. Okay, so my thing is shrinking. Let me have a look at this input, what it should look like. So we're starting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then we should be left with 7. 1, 2, 3, 4, 5, 6. Okay, there's one missing, and also let's do console.log initial state, and if we're doing, do I want to move this over by 40 because I'm adding 2 to it on the left all the time? I guess I want to print this nicely. Okay. Let padding equals 2 times 20 generations. Let s equal, how do I get 20 dots? For let I equals 0, I less than 20, I increases, s plus equals a dot, so I have my 20 dots, and really I want the padding to be this much. And then I want to print padding plus initial state. Oh, weird. The bot deleted all your messages. Sorry about that. I don't think you did anything spammy. I just configured the bot yesterday. No, it was just regular JavaScript. And I saw it and it was all perfectly fine. Can I get those back? Oh yeah. Oh no, this was perfectly fine. Bad bot. Can I moderate the bot? Sorry about that. Yeah, array 20, that fill, and then that join. But a loop is okay too, I guess. Okay. Bad bot. Plus padding. So I'm printing those and I want to padding equals the old padding that slice from 2 to padding that length minus 4. No, we want the endpoint here, right? How did that go from there to there? let a equals 0, 1, 2, 3, 4. So this has length 5. And now if I do a that slice from 0 to 4, then I get 0, 1, 2, 3, 4, 0, 1, 2, 3. I'm a bit confused. 1, 2, 3. The thing has length 5. So I want to go up to the length. So if I do a that slice to a that length, I get the full string, but I don't want the last two ones here. And that did not work too well. Okay, where am I losing? Those should be 7 after one generation, right? 1, 2, 3, 4, 5, 6, 7. Yes. So I'm losing a few parts. And also in this fancy printing, I was assuming they would always stay the same length. So let's have a look at next generation, because this is where I'm already losing stuff. So I'm doing next generation on initial state with the same rules, and then I set initial state equal to next. And I guess, yeah, it doesn't matter. I could have just used always one state. So next generation takes the initial state and adds 2 dots at the beginning and the end. And then it goes through that. Oh, I see. And now I have to, yeah, I see where I'm losing them. How do I fix that? These problems always have quite a bit of those off by 1 errors, but they're fun to think through. Do you see where I'm losing my thingies? I'm not processing the last 5 parts because I always have to take chunks of length 5. So I really want to process all of them. Because they could all turn into something. And okay, I'm looking back at your solution here. So you said you went from I minus 2 to I plus 3. But how do I do that? Okay, for the current part, you want to check the previous 2 and the next 2. Okay, so, but if I don't have them, then I have to like add on some more stuff. So in your solution, the for loop starts at 2. And did you also always make this bigger with the 2 dots here? So for I equals 2, and if the padding on the left is not enough, you added the padding. Yeah, that sounds about right. So I'm going through my string. Okay, I think I'm going through that string because those are the ones that could be filled. And then I can't really slice from negative numbers. So, okay, let's start at 2, which means I need to add the 0 in the first one. I'm adding 2 more so we can subtract these 2 that I added. And then I'm slicing I minus 2 to I plus 3. Oh, now I'm getting ooh, interesting. I get fewer and then I get more. Okay, 1, 2, 3, 4, 5, 6. I'm getting my 7. But they're shifting now, so let me look in the solution. These two should line up for the first 3 generations. Okay, let's fix that. I feel like we're getting somewhere though. This is not completely stuck. Oh, but you said the next one is way harder. Oh well, I don't want to get discouraged by that. Okay, so I'm adding these 4 and somehow they're too far left and they're off by 2. So my padding here should be even longer. My padding, so I'm printing the padding, then I'm cutting the padding off. Where am I even using this left? Oh, that's the counter for how many times I'm going left. And then I'm printing padding next. So if I do that here, that doesn't seem right. Padding, and now I'm pushing them too far to the right. Am I cutting off too much from padding? So the first one has a padding of 40. And then the next one should have a padding of 38. Oh, I guess next is returning the wrong size, because here I added these 4, and I really want to return next that slice to next that length minus 2. Okay, this does not look good at all. Shoot. Yeah, I know the padding is not counted, but I wanted to look good. Wait, you're saying my sum is the right one in this example? Oh, no, 325 was right. Okay, so I made it worse. So let's fix that. Okay, so I have to write sum, but why does it not print nicely? I want this to print nicely, but let's look at that. What's wrong here? Console.log initial state dot length. Oh, the problem is that I'm printing initial state, but then I'm always printing next. Is that my problem? And then console.log next.length. So I'm printing the initial state and then I'm printing these other ones. Let's see. So at first it has length 29 and then it gets 4 longer. So I'm cutting off 2 on the left and 2 on the right. Why is that not correct? Because I say my padding is now 2 shorter. but this one is 4 longer. Where am I losing these 4? And then it gets longer. Okay, let's check on the real input if we get the right number, and then I want to figure out that printing problem. So let's hope for a star. Okay, so this was good. Thanks for your help so far, but I think I want to figure out this printing problem. So git diff, only doing some printing, so let's ignore this for now. Just input. All right, so at first, the initial state is 29 long, and we're padding 40 and 40 on the left and on the right. Okay, and then we're computing the next generation, which is now 33 long because it grew a little bit. Let's double check if that makes sense. Oh, it doesn't matter. It always grows the way that I'm writing it. Yes, because I could have gotten 2 on the left and 2 more pots on the right. And my padding is 1 too short. So what if I slice? Oh, I'm slicing too many off. I'm silly. Okay, I just want this. No? How do I get a substring that's too shorter? Well, maybe I need to do it like this. This looks much better. Okay. So let's not print the length anymore. And then my parts look pretty good. Oh, that was already the, nope. It's kind of weird how commenting code out makes it green. So I always think green is the one that's running, but it's not actually running. Sorry, I'm gonna mess with the font here a little bit. Oh, okay, so after 20 generations, those on the left seem very stable. Could that be right that those on the left are not growing anymore? Yeah, I guess so, because the sample input we had was also stopping. Whereas those on the right, they keep growing out by 1 the whole time. Okay, so back to regular font. And I think we're ready for part 2 now. Okay, you realize that 20 generations aren't enough. After all, these plants will need to last another 1,500 years to even reach your timeline, not to mention your future. Okay, after 50 billion generations. So 50 billion is 50 times 1,000 million, whereas a million is 1,000,000. So we have 1, 2, 3, it's 9 zeros and another 1 from the 50, so 10 zeros, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. Okay. What is the sum of the numbers of all pods which contain a plant? Okay. I think since we can sort of see the pattern when we make a tiny little font, it's somewhat easy to say what it is. So, I'm sorry, I have to make this a bit smaller again. This here is the first generation. Oh, and I can't see anything because I need numbers here, sorry. Okay. So I won't write a computational answer, I'll just look at this picture and then add up the 50,000 to it. I think that'll work quite nicely. Yeah, good luck doing 50 billion iterations. I think I'm not even going to try. But what I did want to do is I wanted to print the number of the pods. And I'm printing that number right before I print this one here. For let I equals minus padding that length, I less than this, I plus plus console that log. Oh, no, that's not gonna work. Let index equal the empty string, and I want to do index plus equal I modulo 10, otherwise everything will be shifted. Oh. Okay, I don't want to add up these. No, this is a string and I'm adding another string, so that should look okay. Index has already been declared. Let marker so what does the marker look like? That didn't work at all. String. No, marker is the empty string, and then let s equal I modulo 10, and then I want to log how can I not do that? So let marker equals the empty string, let I equal 5, marker plus I is 5. Why is this not working? Oh, I think it's because of the order when you do plus equals. No. Anybody have an idea why I cannot concatenate marker with a string? Okay, let marker, let s equal 7 modulo. Oh, no, s is that, and now we do marker plus s is 3. Oh, I have the wrong thing here. Okay. Let I equal padding that length. Padding has a length. I is less than the initial state plus padding I plus plus. What's wrong here? I is equal. Because this is not really a number. That's like the second time I did the exact same mistake today. Okay, so pretty. So we have a marker, we want to mark those, and we want this in a tiny font. And that didn't quite work because I'm printing these stupid minus signs. I'm doing I modulo 10, and then I'm doing plus 10, and then because then it's positive, and then I do modulo 10 again. What does this look like? Perfect. Okay. So I'm starting printing, except now it's so tiny that I can barely read it. Good job. So let's do a few more generations. No, that was too many. Now I can't read it anymore. Let's not do a few more generations. I guess I could cut off these first 20 letters because I know I'm stagnating here. So I'm constantly going, this 0 was my original 0. Is that right? Oh, I don't, this is the test input, so I don't really know, but this 0 is the original 0, and doesn't matter what I do with this pattern, those are stable. We need to reverse the negative marker. Oh yeah, thank you. Thank you, thank you, thank you. Otherwise I'll get wrong numbers here. Okay, that's good to remember. So in the 0th generation, we're starting at 0, and in the first generation, we're starting at first. And it's always that same pattern, and then those are shifting. Do I keep getting more of these columns? What's happening here? Just for fun, let's do 50, and let's make this completely non-readable. And let's see. Okay, why is this breaking on me now? Oh, yeah, because I'm reaching more than these 20, so that keeps growing. So I might have to look at more than 50 just to be sure that I see this. So I always have these. I assumed they would be stable on the first ones. Shoot. Guess I'm not stable. I'm glad that I looked at this. So if we go to 70. Oh, it's so pretty. Okay, so I have this weird point here at which they start moving right. Oh no, they're not starting to move right. I'm silly. That's just because my padding is off. So let me fix the padding. Let me get this to readable again. Okay, so what I do see in my pattern is that I never go more left than -1, and it's stable here. So instead of having this padding of 20 on the left, I'm going to cut this off, because we know for my pattern we don't need that. And let's go back to 20 generations here. Okay, how's the font? Can you all read that okay? Otherwise I can't read. Otherwise I don't have enough on the screen if it's too tiny. Okay, and I want to make my padding on the left. I just want to make that 1. So what I will do is I'll leave out the padding on the left, and I make my initial state. Okay. Let's not jump ahead of ourselves. With padding of 20 left and right. Let's commit just some time in between, otherwise it'll all be messy. So let I equal 0 to initial state plus padding that length, and I want to get rid of the padding on the left. So here I'm just printing initial state, and actually I want to hand print a dot to it. Dot, no, I say, no, I don't do that. Let's see if we can figure that out. Initial state equals 1 dot for padding and the initial state. And then up here we're doing, when we do the next generation, I don't want 4 dots on the left, I want 2 dots on the left. Just so that I can two dots on the left, because then I equals 2 works. Initial statal not found in line 54. Initial state. That's just a little bit too big. And looks like I'm cutting off something here. Oh, and then I'm adding the 20 to it. So I don't want, so for every generation, I just want to print next and the padding on the right. Perfect, I like this. Let's run this. How many generations can we run? What if we do 50 generations? Yep, okay. So what's the pattern here? Ooh, I think after 50 it'll get easier because I have all these doubles. Oh, and what I wanted to figure out was in the 50 billionth generation, that's an even number. And in the even numbers, we're always starting with a dot. So even, so after 1 generation would be this one, but after 50, it's the even one. So we have a dotted -1, and these two are 0 and 1. So we have 0 plus 1. Oh, the sum is incorrect now. Yeah, that's no problem because I'm calculating something different now because I see the pattern here. I will not actually do the whole thing for all 50 billion. I think once I see the pattern, Let's do 100. Teeny font. Ew, this looks so pretty. That looks funny. Oh, I need to go even a little bigger to understand this pattern. I like drawing patterns. Can we do 150? At this point, it's not really a font anymore. Now it's just dots. Nope, too many. Still too many. Okay, shoot, how do I change that back? It would be easier if I had my whole monitor or my work monitor, but I'm working on a somewhat smaller window so that I can screen. So instead of 150, let's do 120. Let's go tiny again. One tinier. Let's make this bigger. Nope, why did it not work? I don't understand this pattern, I have to admit. Shoot. So it looks like at some point every other one is printing, and then I have this weird stuff on the right here. Oh, so I just need the pattern in this row instead of 500 million, and then I have to shift it by however much more it is moving. So it looks like it's stabilized after 150. So I need to correct the sum. Okay, so let's assume stable after 150. Let's make this readable again. Oh, much better, okay. And now I don't want 150, I just want 20 because then I know what the sum should be. So now let's fix the sum here. Okay, your sum is incorrect now. You need to start with 4 dot padding instead of 2. What was I doing for the sum? I get the feeling that I wrote pretty messy code because I already don't remember what I did. So I'm printing the marker. I'm adding 1 on the left for the initial state. Thank you, I feel better now. It was pretty cool how, with your help and like your foreshadowing, it was clear to me that I should not do this 50,000 times and that it was fairly simple to print this so I could see what's going on. And I felt like my pattern was stabilizing really early on. And so, yeah, I feel pretty good about this. Okay, so for these 20, what was I doing with the sum? Let index equals left. Oh, I was doing left as -2. But I don't even need that. I need index is -1. And then I'm going through here. Oh, so I was lucky that was stable at 150 because that was pretty much the end of what I could show on screen. Okay, here's the terminal. 2930. I don't even remember what my solution was. Let's check back. 2930. Okay, so we are back to the correct sum. Did I switch to code again? Yes, I did. So we have the correct sum. So now if we say Please be stable after 200. Then we have another sum. So after 200 iterations, sum is this number. Let 5 billion equal 5, 1, 2, 3 million, 1, 2, 3 thousands, 1, 2, 3. Number that max safe integer. So this minus, oh, good. This is way bigger. Okay, I thought this is another problem here. Okay, so what I want to do is for 150, when it looks stable, sorry, I'm gonna go tiny again. I need to do node day 12. And this is the tiniest. Why does it not fit anymore? Can I like set the terminal to be wrapping? Oh, it doesn't matter. So what I wanted to see by how much I'm shifting in every round. I don't remember if it was 1 or 2, but I can actually do that. Where's my 150? If I just do 30 rounds. Okay, yes, it's shifting by just 1 every round. Okay. You can compare initial state with next to find the exact stable generation. Oh, that's a great idea. Oh, and now I'm happy that I have initial state. Okay, so let's do 300 here. Let's not do all the printing. And let's say if initial state is equal to next, but my next is growing on the right. No, my next is not growing on the right. Console.log, we got stability on I. That is a great hint. I like that, except I never got stability. I think one is a little bit bigger or smaller. Why would they not be the same? Console.log. Oh, because they keep resetting initial state. Gotcha. Yeah. Let me fix this. So, but shouldn't they be identical at some point? So if I do console.log next, because I thought my pattern doesn't change. Oh, great. Not for 300. Why do they keep growing? Oh, they keep growing because I don't shift. Oh, it shifts every time after being stable. Do I need to figure out what the exact one is? shifts after being stable. I need a bigger monitor, then I could see something. I think one of my problems, I guess I can see stuff. Can I see stuff here? Whoa, weird. One of my problems is that I'm padding the dots on the right, and I'm padding too many. No, I'm not padding, well, I'm padding a few too many, but it keeps growing to the right. Yeah, the thing keeps growing to the right, so it's not. Okay, hold on a second. So what kind of stability do we have? I was not thinking that it's stable, I was thinking, okay, and you're saying that they're actually the same? Because I was kind of thinking that it just keeps growing. That was the pattern I was seeing. Okay, yeah, but let's do what you suggested. That actually sounds more scientific than my eyeballing it. Okay, so, and first of all, I need to keep my initial state fixed. So I have the initial state, and then I want to say, where do I have next? Let next equal initial state. And what's wrong with this left? No, it's used, okay. And then here I'm calling next on next, and I do not need this one. And if I'm just going for 20 rows, let's make sure everything's still fine. Okay. Format, git, commit, still fine, working on part 2. Okay, so I have an initial state, and now do I want to print the initial state? I don't think I want to print that. I don't think I want to print the marker. So this is all just debug information. Okay. So if initial state equals next state, but that's not what we want. We want initial state equals initial state dot slice initial state dot index of gives me the first one to whoa, so close. To initial state dot last index of. I would be hopeless without auto completion, so I'm taking first and last one. Let pot area, do I like this name? Let pot area equal next dot slice next dot index of the first plant to next dot last index of the last plant. And now if initial state is the pot area, then we get stability console.log. Let's print the pot area. And then the sum still works exactly the same. And I'm printing still too much console log. I want to print this. Okay, and we never get stability after 20, but what if we run this for 1,000? Nope. Yeah, so I'm ignoring all those, but it's not quite there. So console.log initial state. That looks good. Okay, let's run this for 10,000. Next stat, why am I not getting stability? So you get complete stability where the area was identical to the other one at some point. So I'm not changing initial state in this loop. Padding, that I have a bunch of padding, that shouldn't matter. Oh, and this is not growing linear because my thing is growing all the time. Yes, I'm ignoring the dots. They don't seem to... I'm not finding the exact same repeating pattern. Okay. Part area. So how many did you say yours took to repeat? I mean, mine looks very, very stable. Is it just moving to the right the whole time? Maybe it's just moving to the right. Mine is stable after 300, but it keeps moving. Oh, I think this is maybe the second? No, they just... This is not any of the... Oh, it's one of the... Yeah, let's look at this. So it's always the same. Okay, this is what I started with, and this is kind of the first 20 generations. And then it's still shifting, but at some point it stabilizes. So mine is just stable to itself, not to the initial state. That's cool though. Okay. So, and then how do I get the other number? Every one of my pods shifts to the right by the remaining number of generations. So if one pod shifts to the right, I need to count the number of pods, multiply that by the number of missing shifts, and add it to the sum. Okay. So let previous pod area equal this, and let the pod area, so if previous pod area is equal to the pod area, then we get stability. And then we could print it. So, I still don't have... Why? Oh, because I'm not resetting it, sorry. Let previous pod area equals pod area. Yeah, you need 2 copies inside the for loops. Yeah, that's what I'm trying to do. I was just forgetting to reset it. And now I have pref pod area is that previous pod area. Okay, we got stability a bunch of times. So if we have stability, then we want to break out of the for loop. And oh, but if we're breaking out, we have no idea where we are. No, because before I was running it this many times, but now we're breaking out. So we don't really know where we are. So let's move I out of here. So if I is equal to, so we have I is equal to 1. No, we're increasing this afterwards. So we have to start like this. So here we have a next generation. Is that right? So I'm wondering if I have let I is equal to 1, and then I do for I is less than 3, I plus plus, if I is equal to 1, then I'm breaking. Will that now give me, oh, that gives me I is equal to 1. Yeah, so we are breaking, and because we broke, I doesn't increase anymore. So for the first generation, we have to start with 1 because we already have the 0th generation. So we got stability. We don't really need to see the pod. So now we have some I. And what do we need to do with this I? We need to find the sum . Okay, and we find the sum of next. That sounds good. And now we have remaining iterations equal $5 billion minus I. Because at I we had parity. And so we have this many remaining iterations, and now every pod is shifted by this many to the right. Sum plus equals index, let number of plans equal 0. So this is really the planned area and not the pod area. And if we found a plan, we want to do number of plans goes up. Yep. So now console.log, we have number of plans multiplied by the remaining iterations plus the sum that we already had. Does that sound right? Because that means we have a particular brain. Okay, that is a really good. Oh yeah, it is 50 billion. Yes, so let's say large is large, and then let's copy this number here. Thank you. That would have been so bad. And I'm not sure how long it would have taken me to figure that out. Ooh, yeah, there was totally a 0 missing. Okay. It's still smaller though than the max safe integer, so we're good there. Okay, what was I thinking here? I have a specific configuration, and if it's moving 1 to the right, I have to sum plus every plant increases 1. So the number of plants plus the remaining iterations plus the sum. What could possibly go wrong here, right? Oh, I get stability at 100. Cool. Okay, so I want to make sure if I get stability at 100, I want to make sure I don't have like a weird rounding error here. So if my large number is 120 iterations, and I want to do, that sounds good. Ah, shoot, I deleted that number that I had written down for 300. So here I'm getting 6,931. Yeah, the index increases, and so if the index increases, every plant that I have is increasing by 1 on every iteration, so I'm taking number of plants multiplied by remaining iterations. So I'm getting 6,931 for going to 120. So let's go back to the old formula with large. So git check out this one here, and I wanted to do log the sum for 120. Is it really doing 120? I'm so confused now. 6,931. Okay, that looks good. Git check out master before I get. Put that away. Git check out master. And I think I'm ready. Okay. I don't know, I'm worried that this is wrong and that I do end up sitting here for 10 hours, because with these kind of large numbers, if it's an off by 1 error, there's a lot of ones I could be off, so. Oh my gosh, okay. So how do you say your username? Finn? Flan? Flan? Thank you so much, this was incredibly helpful. I think we had different patterns. Like you said, yours was stabilizing, showing the initial state. Finn test on Twitter. Okay, let me copy that. And I'll be your friend after this on Twitter.